Going to be doing an introduction to test benches. I'm going to start by kind of explaining the test bench VHD file, and then I'm going to show the workflow of creating a model sim project and some organization recommendations for directories that you have your projects in. So for a test bench, or let's say we create this entity, the mux 2x1 from the previous video. Now we want to test it in simulation. The benefit of testing circuits or VHDL files in simulation is that you can see the expected output behavior and see if it matches what you're expecting the circuit to have. In addition, there's some other reasons for more complex circuits that you can create. Analysis and synthesis and code as compile can take very, very long time. Like we're talking a week type of idea. So going into simulation allows you to be able to simulate to see if the circuit's working or not before you waste a week of your life on a circuit that's broken. So anyways, we're going to be testing this mux 2x1 entity. So we have to create a testbench.vhdl file. So I'm going to be showing two different examples. I'm going to be starting with a very simple one that just drives a few signals. And then I'm going to be showing a more thorough / complex one that Dr. Stitt created. So going back to what I was saying before, there's two main components of a VHDL file: entity and the architecture, which stands true here, but test benches are going to be very different from what your regular VHDL files are going to be. So the first thing is that a test bench is just an entity with no input or output. The usual naming convention is to keep the same name and then do an _TB. When we come to an architecture, we're going to want to instantiate signals for all of the inputs and outputs of our circuit. And then when we come here, we're going to have to instantiate it. So imagine that this whole VHDL file is just creating it, defining the behavior, and this is sort of calling that function, if you're thinking of a higher level language example, calling the function of mux 2x1, and we're instantiating it here. The left side are the signals of the actual circuit. With the right side, it's the signals that we're connecting them to. Because we need to do this because just imagine this mux 2x1 is a black box. We can't interact with it unless we have signals to drive. So once we instantiated our circuit, we're going to come into the process. Now, test benches are just driving input signals and having the software, whether it be Model SimQuest or anything, simulate the outputs. This is good to see if we have the expected behavior of our circuit working correctly or not. So again, this is just a very simple test bench. I'm driving both inputs to this value of 1. The select is 0, should output 0. I'm going to wait for 10 nanoseconds so that I can see the output. And I'm going to do select 1, and it should also be 1. Now again, this is a very, very simple test bench. After this, I'm going to show a more thorough test bench. But if you understand the fundamental concept that test benches are just there to drive input signals, to simulate the output signals in the software you're using, that's it. Regardless of the complexity, you should be able to understand any test bench from that. So this is the simple test bench. Now, if we go into the more complex test bench, this is from Dr. Stitt's GitHub. There's a lot going on here. So again, a lot of the same stuff. We're going to keep the same mux here, instantiate the same mux. We're going to have a couple signals to be able to interact with it. But the process is, there's a lot more going on. First thing is that he defines a function. This is a function that he uses. It's the exact same behavior, but the point of it is, again, it looks kind of redundant since this is a simple application, but the point of it is that he's going to compare this output to the output of the mux circuit that has already been created. And they should be equal because this is the behavior we're looking for. We come into the circuit and he has a loop here. He has a loop because there's 8 input combinations for a 2x1 mux. Remember, this is a thorough test bench. Thorough meaning we want to test everything. And the loop's just going to iterate through and test all of the inputs. So there's a lot going on here. There's an assert, there's a report. A report statement in a test bench is basically just the equivalent of printing in a higher level language. A print function that allows you to print to the console. And then here it's just printing the output, or the inputs, and then comparing the outputs in this assertion of the mux test to whatever the output of the circuit is. And it's just, again, exact same thing. We're driving inputs, and then we're seeing what the outputs are. The outputs are simulated in the software. Now we're going to be creating our model sim project. Now again, model sim, Quartus, two separate softwares. You're going to have to create a Quartus project for each lab and a model sim project for each lab. So something I highly recommend for organizational purposes, this black box folder I have here, let's say it's just lab one or lab two, whatever it may be. You want three folders in here. You want a model sim folder, you want a Quartus folder, and you want a VHDL folder. VHDL is going to hold all your VHDL files, simple enough. Quartus, you're going to put your Quartus project in there, and model sim, you're going to put your model sim project in here. The purpose for this and kind of keeping everything separated from each other is sometimes you might break a Quartus project. If you want to delete it without deleting anything else, like your VHDL files or your model sim, you can just delete this folder kind of thing. And organizational purposes, this keeps everything separated from each other. So I'm going to go in here and select this folder to create the project for. Now it creates the model sim project. I want to add existing files because I already created the VHDL files. I'm going to go up a directory. Another benefit to the organizational purposes are all in one spot. We're not testing the add, but we're testing the mux. Actually, we'll add the adders in here as well because it makes a point. So you can have multiple files in the model sim project. And another thing about model sim is very good for compiling. I can compile all. Let's see, there's a couple of errors. Let's see what those errors were. And add underscore TB and mux 2x1. Let's see what this is. I actually don't know what this is. Oh, wait, I didn't add anything to that. We're going to get rid of this just because I didn't do anything to this file. If you remove a file from the project, when it says delete from disk as well, that means it will just delete the file completely. So don't check that. Most of the time, that's not what students want. So we'll compile again. Okay, mux 2x1.vht failed with one error. Let's double click this. This is the whole debugging process. Let's see. Line 25. Something's going on line 25. Sometimes the error doesn't really make a lot of sense. There's something it's trying to assume what the problem is, but we know it's on line 25. So let's go to line 25 and see what we find. And there it is. I put that in there just as an example. So just by looking at it, we see the problem. A lot of times it's going to be an obvious syntax problem. You can just fix it right then and there. Save that, back into here, and compile all. There we go, failed with no errors. Once we reach this point, then we can finally simulate. So if we go to the Simulate tab, Start Simulation, we can ignore that. Now, what I was saying before is that you can have multiple files in here. So I'm using this to test the mux test bench, but it doesn't matter because when I come in here, I'm just going to click the test bench I want to run. So I'm only going to run the simple test bench. I'll click it, click OK. It's going to load. Model sim is very slow. The other thing is that you can tell it's made by the engineer by the fact that it looked like somebody threw up and then buttons were created. All right, so once we're in here, we have our instance here. When we click our instance, it's going to pop up with all these signals that we created in our test bench. And we're going to want to carry all of these over to here. Another thing is that you notice it has the entity name, and it's like a directory path almost. If you come to all these 6 icons here, this one, another thing is if you hover over an icon, it's going to tell you what it does. Toggle leaf names. If you click that, it's going to look way nicer. All right, so we have our signals in our wave window here. Now we want to actually run the simulation. So we're going to click run, run all. All right, and then the simulation runs. It's only 20 nanoseconds, which makes sense. I had 2 wait for 10 nanosecond statements. It was, again, a very simple test bench. And inputs are 1 the whole time, just like how I had them in the test bench. And then I had select 0 for 10 seconds and 1 for 10 nanoseconds. And then the output stays as 1 the whole time. Now, this process you're going to apply to any test bench you're ever going to do, even if it's the complicated or thorough test bench. It's the exact same process. And you can go through here, see what the problems are, and be able to debug it from that. Another thing that I see students do is that I'll see them like exit out of this window when they change something on their files. You could do everything from here. So I can go to compile and compile all. You can see everything still compiles perfectly fine. And then if I want, I can simulate and restart after compiling and there's new code in there. And then I just restart the simulation. I don't have to worry about bringing any signals back into here and that kind of thing. Okay, in this video, we did a little bit of an introduction to test benches. We started with the simple mux test bench, showed a thorough mux test bench, and that at the basic level, they're both the same thing. They're driving input signals so that the software can simulate what the output is supposed to be. And then I showed the workflow for model sim.